Hi, I'm Ashwin Noria.
I'm Nathan Pinnell.
And I'm Jamila Middlebrooks, and we are Group A9.
And we did our presentation on the prevention of malaria through the introduction of genetically modified bacteria to the gut of mosquitoes.
Hi, I'm here to introduce our presentation to you. Malaria, although it is one of the most common diseases, it affects nearly half the world's population and kills about 1.2 million people each year. By the simple bite of a mosquito, the Plasmodium parasite can be transmitted into our bloodstream, thereby infecting us. And not everyone has access to a vaccine, like in the developed countries. In the less developed countries, people die because of this particular reason. And due to this, I would say people are craving a more preventive measure, or a better weapon to fight this war against malaria. And biologists believe that this weapon could be genetic modification. And we will talk about this more in detail in the other slides. Thank you.
So in terms of data and results, there's been numerous unsuccessful attempts to eliminate malaria in the past, and mostly these attempts have been through genetic modification of the mosquitoes themselves. However, this doesn't always work because the mosquitoes, which are known as Anopheles gambiae, you can't simply genetically modify the wild type because, for one, you'd have to basically rely on the mosquitoes' genetic modification, like the selection for them to select for the mosquitoes that you've modified. And also that's the same reason why you can't just genetically modify a bunch of mosquitoes and release them to the wild, because you'd still have to rely on natural selection, which isn't always the most useful tool because it'd be random. So the researchers in the article that we read decided that the best way to prevent the spread of malaria was to cause a symbiotic bacteria known as Pantoena agglomerans to secrete a protein harmful to the Plasmodium. And this was done through the addition of a hemolysin A secretion system from a familiar bacterium, Echinacea coli, which is more commonly known as E. coli. And the proteins secreted from this Pantoena agglomerans were served to inhibit development of both human malaria, which is known as Plasmodium falciparum, and rodent malaria, which is known as Plasmodium bergii. And basically, this approach reduced the prevalence of both human and rodent malaria by 98%, which was basically inhibiting the oocytes, which is when the Plasmodium is transferred, it causes the production of mass amounts of oocytes, and it inhibited their growth. And also, only 14 to 18% of the mosquitoes that drank blood from an infected human ended up contracting the malarial disease, which caused their oocytes to grow, which was down from 90% of mosquitoes that didn't have the bacterium present. And the greatest decreases were from two specific proteins, which are known as effector molecules, called scorpium and EPIP4, or EPIP4. However, the problem is spreading the bacteria can be difficult because, for one, humans aren't exactly inclined, like a lot of local populations aren't exactly inclined to want to have this genetically modified bacteria in their just population spreading wild. Very difficult to plant, to get the bacteria into the guts of mosquitoes to make a difference. So it can be rather difficult. So it's mostly just a logistics problem for getting the solution to fruition. So basically, this picture shows a diagram of how the malaria is transmitted from mosquito to mosquito. But basically only this upper half is important because the rest is how this affects humans. So basically the mosquito will bite an infected person, and then inside the mosquito, the oocytes will grow and the Plasmodium will spread into the gut of the mosquito, and then the oocytes will grow and the parasites from the oocytes move into the salivary glands, and then it'll bite another human, and then it'll cause malaria to shift to the liver.
And now we'll be doing the discussion. Malaria is a widespread epidemic. The mosquito midgut serves as a prime target for blocking parasite transmission with engineered bacteria. The Plasmodium agglomerans are excellent candidate for delivery of anti-malaria to mosquitoes. And that is our discussion.
And now I will talk to you about the conclusion. Scientists have found a way to manipulate mosquitoes by using the most important function of a mosquito, the gut. And by doing this, they are able to interfere with P. falciparum, and this is up to 98% effectiveness. This genetically engineering method is very useful for saving lives in the future. And if you look down at this picture shows how widespread malaria is, and thus is very important for there to be a way to improve human life. And here's our literature cited. And we have images and also our important article